Now, Isaac Newton talked about the binomial expansion. He talks about the binomial theorem. Now, this time around, we'll be talking about the binomial theorem, the word binomial. Binomial from the word bi, it means two. Now, we have trinomial as well. If you have something like 5x minus 3y, see this one, raised to power 3. Now, this one is binomial. But if you have something like, let's say, 7x plus, let's say, 2y minus 8. This one is now trinomial. Trinomial expansion. Let's say maybe it's raised to power 4. This trinomial expansion. Now, we'll be looking at binomial expansion. I will not be talking about trinomial expansion these days. Now, let's talk about the binomial expansion. Now, for the binomial expansion, the binomial has a formula. We'll be talking about the three aspects here. We'll be looking at the formula aspect. I'll be looking at the Pascal triangle. The Pascal triangle. And I'll be talking about the calculator method. The calculator method of binomial expansion. Now, the first question, the first aspect, the formula method. Now, for the formula method, the formula says if you have n summation, we have r to be equals to 0. From 0, we start from 0. Then the formula is n combination r, a raised to power n minus r, then b raised to power r. This is the formula. For instance, if you're asked to expand, let's say, x plus y, all raised to power 5. X plus y, all raised to power 5. Then if you want to expand this, we now start by saying the expansion of this will now become, we are going to be following the formulas here. That means this is our n. You know, this is our n. This is our A, this is our B. So you are going to relate it to something like this. A plus B, always power n. So this is our n, this is our A, this is our B. So therefore, let us start. That means you will not be starting from 0. You just, the only thing you'll be doing is that you'll be increasing your R from 0 to the last power here. So the first one is n, which is 5. So we have 5, then combination R. Don't forget that I said you are going to start from 0. Then you have A. What's our A here? X. The raised to power n, which is 5, minus, what's our r we are using here? 0. The b here, what's our b here? That's y. The raised to power r, which is 0. Plus, the second one, you start from 0, r to be 0, then 1, 2, 3, 4, to 5, which is the largest number. Assuming this power is 7, that means you take it to 7. Then the second one will be 1. That will be n, which is 5, combination 1. Then a is x, raised to power n, which is 5, minus 1. Then b, which is y, raised to power 1. Plus the third one, that has 5, combination 2. X raised to power 5, minus 2. Then y raised to power 2. Plus the next one, that has 5, combination 3. X raised to power 5, minus 3. Y raised to power 3. Plus the next one, which is 5, combination 4. X raised to power 5, minus 4. Y raised to power 4. Plus the next one, which is 5, combination 5, x raised to power 5 minus 5, y raised to power 5. Now, you now start again from here. 5 combination 0. Don't forget, the reason why I will not be using combination here is because I've not taught you about the combination. Now let us go. What is 5 combination 0? 5 combination 0. This is how to press. Let me press it again. We have 5 here. Shifts. This combination, then 0. You have 0. The answer is 1. So because 5 combination 0 is 1, that's 1. Then x raised to power 5 minus 0, that will be x raised to power 5. Y raised to power 0, anything raised to power 0 is what? 1. Plus 5 combination 1. 5 combination 1, if you press on the calculator, that's 5. Then shift. Combination here, then 1. The answer is what? 5. Then you have this to be 5. Then multiply by, let me put dots to represent multiplication. Multiply by x raised to power 5 minus 1, that's 4. That's x raised to power 4. Then y raised to power 1 will be what? Y. That's multiplied by y plus 5 combination 2. 5 combination 2. 5 combination 2 will give you 10. So that means we have this to be 10. Then x raised to power 5 minus 2, that's 3. Then y raised to power 2 plus 5 combination 3 will give us, let's press it, give us 10 as well. So 5 combination 3, that's 10. Then x raised to power 5 minus 2, that's 5 minus 3, that's 2. Then y raised to power 3 plus 5 combination 4, that's 5. So since you have this to be 5, then y raised to power, x 5. Then x raised to power 5 minus 4, that's 1. Then y raised to power what? 4 plus 5 combination 4 will also be 1. And multiply by x raised to power 5 minus 5, that's 0. Then y raised to power what? 5. If you press the remaining values here, this will be 1 times x raised to power 5 times 1. The answer will be x raised to power 5. Then if you press here, you have 5 multiplied by x raised to power 4 y plus, this one will be 10 x raised to power 3 y raised to power 2 plus 10 x raised to power 2 y raised to power 3 plus 5 x y raised to power 4 plus anything raised to power 0 is what? 1. So this one is 1. 1 times 1 times y raised to power 5, that's y raised to power 5. So this is the expansion of this formula here, of this value here. Now the next aspect. We are still under the formula aspect. Now, before I will now go into the Pascal triangle, now, if you are asked to expatiate, let's say you are asked to expatiate 2x plus 3y all raised to power 3. 2x plus 3y all raised to power 3. If you are using the formula is n combination r dot a raised to power n minus r dot b raised to power r. Now, so that means this is our a, this side is our b, and these are what? N. So you now start your r from 0. That means we start r from 0 to 1 to 2 and to 3, because the largest value here is what? Is 3. So we end it at 3. So the first one, our n is 3. Then combination was our r 0 dot a. Our a there is 2x. The raised to power n, which is 3 minus 0. Into bracket, our b is 3y, the raised to power 0, plus, we move to 1. So that means we have n, which is 3, combination r, which is 1. You know, we've used 0 here, we need to migrate to what? 1. Then a, and our a is 2x, raised to power n, which is 3, minus r, which is 1. Then our b, which is 3y, the raised to power 1, plus, we migrate to 2. That will be 3 combination 2. Then to bracket a, which is 2x, raised to power 3 minus 2. Then to bracket b, which is 3y, rather, raised to power 2. Plus, we migrate to 3. That's 3 combination 3. Then to bracket 2x, raised to power 3 minus 3. Then 3y, raised to power 3. Now, we'll now do something. Now, what is 3 combination 0? 3 combination 0 will give you 1. So we now have this to be 1 multiplied by, expand this. This one will be 2x raised to power 3 minus 0 will be 3. Then don't forget that all this will be 0, because anything raised to power 0 is what? Sorry, all this will be 1. Because anything raised to power 0 is what? 1. Multiplied by 1 plus. Now, 3 combination 1, if you press it on the calculator, it will be equal to 3. So 3 combination 1 is equal to 3 multiplied by, then open this place. This way will now be 2x raised to power 3 minus 1, which is 2. Then into bracket 3y raised to power what? 1. Plus this one. 3 combination 2 will give you 3. So this place is also 3. We have 3, then to multiply by 2x raised to power 3 minus 2. That's equals to 1. Then 3y raised to power what? Raised to power 2. That is here. Then plus this one, 3 combination 3 will be equals to what? 1. Then 2x raised to power 3 minus 3 here. That's equals to 0. So 3 minus 3 that is here is 0. So because it's 0, then you now have multiply by 3y raised power what? Raised power 3. Now let us now see. Now you now believe that this becomes 1 multiplied by. Now see this one. Let us open this one after the other. We have 2 raised power 3 x raised power 3 multiplied by 1. Don't forget, in the law of indices, if you have a multiplied by b all raised power, let's say 6, then you have it to be a raised power 6 and multiplied by b raised power 6. So this power belongs to both value inside the what? Inside the bracket. So that's what happened here. So because of this, we have it to be 2 raised power 3, then x raised power 3, then plus 3 multiplied by. This one we share the power as well. That's 2 raised power 2, then multiplied by x raised power 2, multiplied by 3 raised power 1, y raised power 1, plus, don't forget, I use dot to represent multiplication. I don't want to use x because x can seem like multiplication. So that's why I'm not using multiplication sign. So multiplication signs can look like x. So that's why. And let's proceed. This multiplied by 3 multiplied by, this one is raised power 1. That's 2 raised power 1 multiplied by x raised power 1. Multiplied by this one as well. 3 raised power 2, then y raised power 2, plus the last one here, that's 1. Multiplied by n raised power 0 here, that's 1 as well. Multiplied by 3 raised power 3, then multiplied by y raised power 3. And let us start. If we check this, you now have this to be 2 raised power 3. Will give you a value. Because 2 raised power 3 will be equals to 8. So you can see that this one is 1 times 8. So we now have it to be 8 x raised power 3 plus, because n raised power 2 raised power 3 is 8. So we have x raised power 3. This one is 1. So that's 1 times 1. That's 1. Then this one as well. 2 raised power 2 is equals to. So let's use the calculator straight up. We have 3 here. So 3 here multiplied by 2 raised power 2. Then multiplied by, we have a number here as well. Multiplied by 3. That's all. Multiplied by 3. That's all. And the answer is 36. We now have it to be 36. Then what are the alphabets? Alphabet is x raised power 2. And we have what? Y. Plus. The next one. Next one here is, we have 3 multiplied by 2 that is here. Then multiplied by 3 raised power 2 that is here. What's the answer? Those are the values. We have it to be 54. So plus 54. And what are the alphabet? That's x and y raised power 2. So we deal with the alphabet, the numbers first. We multiply all the numbers. Then we now multiply the what? The alphabet. Plus, what's the number that is here? 1 times 1, that's 1. Then 3 raised power 3 will give us 27. Will give us 27. So we now have this to be 27. Then y raised power what? Y raised power 3. This is the expansion for 2x plus 3y all raised power 3. Now I will draw my example on this one. Now I've explained the formula method. Let us go into the Pascal triangle. The Pascal triangle is explained because it is triangle. You are going to start with 1, then you end with 1. That's the principle for Pascal triangle. Let us start. We have 1 here. We have 1. We have 1. We have 1. 1 plus 1 will give us 2. Then we have 1. We have 1. 1 plus 2 here will give us 3. 2 plus 1 will give us 3. We have 1. We have 1. 1 plus 3 will give us 4. 3 plus 3 will give us 6. 3 plus 1 will give us 4. Then we have 1. We have 1. 1 plus 4 will give us 5. 4 plus 6 will give us 10. 6 plus 1 will give us 10. 4 plus 1 will give us 5. We have 1. We have 1. 1 plus 5 will give us 6. 5 plus 10 will give us 15. 10 plus 10 will give us 20. 10 plus 5 will give us 15. 5 plus 1 will give us 6. Then we have 1. Now, that is how you do the Pascal triangle to the last. Let's do one more. 1 plus 6 will give us 7. 6 plus 15 will give us 21. 15 plus 20 will give us 35. 20 plus 15 will give us 35. 15 plus 6 will give us 21. 6 plus 1 will give us 7. Then you have 1. This is what we know as the Pascal triangle. As you all see that the arrangement is like triangle. Now, how do you use Pascal triangle? The first one here is used when the number of power is equal to 0. That is when the power is 0. This one is used when the power is 1. This one is used when the power is 2. This one is used when the power is 3. This one is used when the power is 4. This one is used when the power is 5. This one is used when the power is 6. This one is used when the power is what? 7. Now I'm going to use this Pascal triangle to solve this question we solve at the top here. And let's solve it again. That's 2x plus 3y all raised to power what? 3. Now how we use the Pascal triangle to solve this? The Pascal triangle is solved. Now, the first thing you need to do is that for the Pascal triangle, you have to check the power of this. You have to check the alphabets at the left side and the alphabets at the right side. Now the thing is that the alphabet at the left side will keep decreasing and the alphabet at the right side will keep increasing. What am I talking about? What I'm talking about is that, take all the values at the left side to be decreasing and this one will be increasing. This one will be decreasing. This one will be increasing. That's a property. Now, what are we talking about? Now, this is it. You have the left side, which is 2x. It will start from the highest power, which is 3. And the right side, which is 3y, that one will start from 0. Now, you now have the next one, you now have plus. The next one will now be 2x. You know it's 3 here, it will be decreasing. So it will now be what? 2. Then the 3y will now be raised to power what? 1. So as this one, so the next one will now be plus. Oh yeah, that will be 2x raised to power 1. Then 3y raised to power what? So this one is 3, this one is 0, this one will be 2, this one will be 1, this one will be 1, this one will be 2 like this. And plus the next one, this one will be 2x raised to power 0, then 3y raised to power what? Raised to power 3. Now can you see, as this 2x decreasing, the 2y at this side increasing. That's 2x here is 3 before, becomes 3, it becomes 1, it becomes 0. Then we check this 2y is 0, then becomes 1, becomes 2, because so just start the power from anywhere. You can see that the power here is what? Is 3. That's why we start from 3. Assuming the power here is 5 here, that means the power here will also be, it will start from what? 5. So this one is 5, this one will be 0, this one will be 4, this one, you understand? So you start from what? From the highest power. Then after you have done this, you will now introduce the coefficients of when the power is 3 at the Pascal triangle. And when the power is 3 is this. So what's the coefficient? This is the coefficient. The coefficient is 1, 3, 3, 1. So let us now expand. We want to expand this now. This one, we have to separate it, which will be 1 multiplied by, you can see that 2 here is raised to power 3 here, then multiplied by x raised to power 3 that is here. Anything raised to power 0 is 1. So multiply by 1. Everything inside this space is 1. So plus this side now. This side will now be 3 multiplied by, oh yeah, that will be 2 raised to power 2. Because we have to expand this. 2 raised to power 2. Then multiply by x raised to power 2. Multiply by, this one is raised to power 1. So we have to take it one after. That's 3 raised to power 1. Multiply by y raised to power 1. Plus, let's take this one. That will be 3 multiplied by 2 raised to power 1. Then multiply by x raised to power 1 as well. Then multiply by 3 raised to power 2. Multiply by y raised to power 2. Then plus, let's take this one. This is 1 multiply by anything raised to power 0 is 1. Then multiply by 3 raised to power 3. Then y raised to power what? Y raised to power 3. Then when you have this, you believe with me that this one will now becomes 1 multiplied by 2 raised to power 3 is what? 2 raised to power 3 is equals to 8. So we now have it to be 8. Then what do you have here? We have x raised to power what? X raised to power 3 plus, this one is multiplied by 1. So everything is, that's 1 times 8 times 1 that is here. So you firstly multiply the number, then you now add the alphabet that is there with it. So 1 times 8 here times 1, because 2 raised to power 3 will give us 8. So 1 times 8 times 1 here, which gives us 8. Then what's the alphabet there? X raised to power 3. This side is 3 times 2 raised to power 2, that's 4. 3 times 4, that's 12. Times 3 that is here will give us 36. So that means we have plus 36. Then what are the alphabet that is there? These are the alphabet, which is x raised to power 2, then y, plus, let's get to this place. This 3 multiplied by 2, that's 6. Times 2 raised to power 2, 3 raised to power 2. 3 raised to power 2 is 9. So we now have 3 times 2 times 9 will give us 54. So that's 54. Then what are the alphabets? This alphabet x here, and this y raised to power 2. Plus the next one here, that's 1 times 1, that's 1. 3 raised to power 3 is equal to what? 37. So we now have it to be 1 times 1, that's 1 times 27. 27 rather. That's 27 y raised by what? Y raised by 3, because you only have y raised by 3 here. So this is the expansion. Can you see that it is equal to this? Using this, we use the what? The formula here, and here we use the what? The Pascal triangle here. Now the last aspect. I'll be solving this aspect with the use of the binomial, with the use of David calculator shortcut. David calculator shortcut. Now what is it? Now assuming you are asked to find the same thing, 2x plus 3y all raised by 3. I'm going to expand this. It is 2 steps. Now let me bring the calculator here so you can see better. Now, 2 steps. Now what's the 4 steps? The first steps is that you will firstly deal with alphabet that is here. So as the alphabet here decreases, alphabet here will increase. So let us see. So what's the alphabet here? That's x. So as I have x raised by 3, y will be raised by 0. As I have x raised by 2, y raised by 1. As I have x raised by 1, y raised by 0. As I have, x raised by 3, y raised by 0. X raised by 2, y raised by 1. X raised by 1, y raised by 2 rather. Then x raised by 0, y raised by 3. So as the alphabet here decreases, alphabet here increases. So now, once you are done with the alphabet here, you are good to go on the calculator. What's the formula you are going to know? The formula for the calculator is n combination x multiplied by a raised power n minus x multiplied by b raised power x. So I'm using the general formula, but I only change r to what? To x. So let us see. So this, the number that is here is my a, number that is here is my b. This one is what? Is my n. So let us now see. I will now press on the calculator. I press mode. Then after I press mode, I press my f of x, which is stable. That's number 7. Then I will now be following this formula. So if I want to do it, I will say open the bracket, n into bracket, n combination x, close the bracket, then open the bracket a raised power n minus x, close the bracket, then open the bracket b raised power x. So this is how I'm going to put it on the calculator. Then let's follow the formula. So open the bracket. What's my n here? Don't forget n is 3. So I have 3. Then combination. What's combination? I have shift this place. Then what's x here? That's alpha. And we have x here. Alpha, close bracket. Then close your bracket. When you close the bracket, open the bracket again according to the formula. Then we have a. What's the coefficient of, what's the a here? Which is the number only. That's 2. 2. Then raised to power. What's our n here? Our n here is 3 as well. That's 3 minus. What's your x? We have x. Come to this space. Then close the bracket. Open the bracket again. We have b here. What's our b here? Our b is 3. Then raise to power alpha x. Then close the bracket. Press equals to. Now you are going to always start from 0. So press 0 and press equals to. And your end will always be at the highest power here. And the highest power is 3. Press equals to. Then your step, leave it as well. Press equals to. Now can you see you have your table? Now at your table here, when you have your x, when you have your x to be 0, what's the value out there? The value under f of x here is 8. So you have here to be what? To be 8. Plus, when you have it to be 1 here, what's the value here? We have it to be what? 36. So this next one is what? 36. When you have your value here to be 2, what's the value here? That's 54. So if you press it down as well, the next one, when you have it to be 3, what's the value? That's 27. So this is the answer to the what? To the value we have here that we solve using the calculator, using the Pascal triangle and the normal formula. So this is how you do it on the calculator. So that's why we have it to be 8 x raised by 3. Can you see that n raised by 0 is what? 1. Then plus 36 x raised by 2 y plus 54 x y raised by 2 plus 27 n raised by 0 is 1. So we remove this x raised by 0, then y raised by 3. So can you see that is the same thing with the what? With the previous question. Let me solve one more on this calculator method. Now imagine you are asked to find the question like this. Now imagine you are asked to find the question like this. imagine you ask to find, if you ask to expand x minus 3y all raised to power 5, expand x minus 3y all raised to power 5. You know the first method is to deal with alphabet. X is here, y is here. So I have x raised to power 5, y raised to power 0, x raised to power 4, y raised to power 1. So as x decreases, y increases. X raised to power 3, y raised to power 2. X raised to power 2, y raised to power 3, x raised to power 1, y raised to power 4, x raised to power 0, y raised to power 5. So anything raised to power 0 is 1. So this one is 1. This one is also 1. So now let me deal with the alphabet. So you press your mode, you go to table, that's number 7. When you get to table, then let us follow the formula. That's open the bracket of n. Don't forget these are n, these are a, these are what? B. So you now have into bracket your n, which is 5. Then shift combination here, then your x, alpha x, close the bracket, then open the bracket, we have a. What's our a there? 1, because coefficient of x here is 1. So 1 raised to power, what's our x, what's our n? Our n is 5, so press 5 minus our alpha x, press forward direction so that you can close the bracket, open the bracket again. What's your b? Your b is minus. So because b is minus, I have to open another bracket. So let me put that minus 3 inside bracket. Can you see that I put minus 3 inside bracket because if I don't put it inside bracket to give me different values. So now the raised to the power of, what's the value of this? We have x, and what are x? We have x. Then come and close the bracket, press equals to. I told you start from 0, so press 0 and press equals to for start. Your end at the largest power here. And what's the largest power here? 5. So press 5 and press equals to. Step, don't touch anything about step, just press equals to. So I press equals to, can you see the value? Now, for the value we have here, when you have it to be 0 here, when you have it to be 0, what's the value here? We have 1. So this place is 1. Then we now have plus. Oh no, the next one is minus. Can you see? When it is 1, it is what? Minus 15. So this is minus 15. So this one is not plus, it's minus 15. So let me rewrite. That's 1 x raised to power 5. Now I have minus 15, x raised to power 4, y raised to power 1. Then let's see the next one. Next one, when you have it to be 2, what's the value? You have it to be, can you see? You have it to be what? To be 90. So this place you have it to be plus 90, then x raised to power 3, y raised to power 2. Then when you have, let's scroll down. Let's scroll down. When you have it to be 3, when it is 3, we have the value to be what? Minus 270. Now have it to be minus 270. Then what do you have here? That's x raised to power 2, y raised to power 3. Next one is this. So what's the value here? We now have the next value to be what? Plus 405. So plus 405, x raised to power 1 here, then y raised to power what? 4. Then the next one is minus 243. Minus 243, then what we have here is y raised to power what? 5. That is all. Can you see that? We all have the values on our what? On our calculator. This is how you do the what? The binomial expansion on the calculator. Can you see that? We now, you know how we got the what? The alphabet, and you know how we insert the what? The coefficient. So this is how you find the coefficient. And if they ask you that you should find the greatest coefficient. Now, the greatest coefficient here, you can use your calculator. Like if you check all the coefficients you got here, which one is the largest? The largest is 405. Now that is how to pick your greatest coefficient or your largest coefficient. Now this is how to do this. Now in the next class, I'll be doing the binomial expansion of negative power. Now if you use this same calculator method for the one of the negative power, it's not solved. Like the calculator will not solve it. But on this channel, I'm going to release it for you so that you can practice more on this. So we have the way to do the binomial expansion of negative power on the calculator as well. So please and please follow us for more calculator videos. Share, like, and comment for people to view the channel. Thank you very much. I remain Ishola David Blessing. Thank you very much. Popularly known as General David. God bless you. Now at the comment section, let me know. Expand this using the calculator method. Expand this using the calculator method. Expand 3x minus 2 all raised to power 3. 3x minus 2 all raised power 3. Then out of this, what is the largest coefficient here? We have 54, we have 27, we have 34, we have 36. Now what's the answer? When you expand this using the same calculator method, now when you expand like this, now as I pick 405 as the largest number here, now see which one is the largest coefficient when you expand this one. Let me know at the comment section. God bless you. Thank you very much.